All right, in this video, I'm going to go over with you how to evaluate and graph piecewise functions. All right, so when we look at piecewise functions, what we're looking at is certain rules based on what the domain values are. So let's look at problem number one. So we have the piecewise functions, function t of x. And in the first case here, we want t of 1. So what we need to do is we need to look at the rule and see where 1 fits in the domain. So in this case here, 1 is less than 2, so we're going to use the top part of the rule to evaluate. So what we would do is we would plug in 1 for x, and we would get 2 times 1 minus 5, so we would get negative 3 as our answer. All right. Problem 2. We have 5 halves, and 5 halves is 2.5, and 2.5 is greater than or equal to 2, so we're using the bottom rule, which is the reciprocal 1 over 5 halves. So this would evaluate to the reciprocal of 5 halves, or 2/5. All right, problem number 3. We have t of 0.25. 0.25 is 1/4, which is less than 2. So we're using the top part of the rule. So we would get 2 times 0.25, and remember 0.25 is a fourth, minus 5. So we would get 1/2 minus 5, and 1/2 minus 5 would be 1/2 minus 10 over 2. So we would get negative 9 over 2 as our answer for problem 3. All right, the next one, m of x. We have a different piecewise function. We have the square root and we have absolute value. So we want m of negative 1. Now here's an interesting scenario with number 4. Negative 1 is not in the domain because neither of these have an equal sign as part of their inequality. So this one for number 4 would be no solution. Problem 5, m of positive 1. Again, well, no, in this case here, positive 1 would be greater than negative 1, so we're using the bottom rule. So we would plug in 1 into the bottom part of the rule, and we would get 4/5 minus 3, which would be 4/5 minus 15/5, which would be negative 11 over 5 for that rule. All right, problem 6, m of negative 8. Negative 8 is less than negative 1. So we would get 1 minus negative 8, square root of 1 minus negative 8, which is the square root of 1 plus 8 when we simplify this, or the square root of 9, which in this case here would be 3 or negative 3. All right. So number 7, let's graph and state the domain and range in interval notation. Okay, so when I graph in interval notation, what I want to look at is I want to look at the domain values here, right? And we want to see where the graph can change or can break off. And we can see that negative 1 is a breaking point in this graph, possibly. So what we want to do is we want to look at the values at negative 1 for both parts of the rule. So for example, for the top rule, when we have x less than negative 1, that means we're going to have an open circle at negative 1 into the rule, when negative 1 is plugged into the rule. And for the bottom part of the rule, since it's greater than or equal to negative 1, we're going to have a closed circle at that value. And sometimes the open circle and the closed circle will overlap each other with a closed circle. And we might see that as we're graphing these. All right, so let's do the top rule. So if I took negative 1 and plugged it into the function, I would get 2 times negative 1 minus 1, which is negative 3. So that means at negative 1, I have the value negative 3, and I'm going to have a open circle. Okay. And for all the values less than -1, it's going to follow the rule of the line 2x minus 1. So we have to graph what 2x minus 1 would look like to the left of -1. And I can see here that I have a slope of 2. So I'm going to work backwards with a slope of +2 down 2 into the left 1, which creates a +2 slope. So what's happening is my graph is actually working this way. All right. Okay, let's look at the bottom part of the rule. So when x is greater than or equal to -1, we have the constant 3. So at -1, we would have a closed circle at 3. And then what would happen is that this would be constant as we oh, as we move to the right here. Okay? So what's the domain? And we want to use interval notation for the domain here. Well, all of our x values are accounted for here because we go x less than -1, but then we go x greater than or equal to -1. So our domain would be -infinity to +infinity. Now, what about the range? Okay, so now with the range, we know for this part of the graph here that we started out from -infinity up to not including -3 because of the open circle. So I'm going to have a parenthesis there. And then we have to account for the constant 3 as part of our range. So there's a couple ways to do this. In interval notation, we can just say bracket 3 to 3, that would include 3. Or if we wanted to, we can write it in set notation as a single member of the set of 3. All right, so that would be how to graph number 7. All right, number 8, sketch, state the domain and range in set notation. So we'll use set notation here instead of interval notation when we do the domain and range. So now we have 3 parts to the rule. And so let's start at the top. So I can see this is going to be closed circle because x less than -2. So when I plug in -2 into the rule, I'm going to get the opposite of -2, which is 2. So let's go to -2, 2, and we're going to put a closed circle. And the rule is -x, which is a line with a slope of -1. So that means for all the values less than or equal to -2, the graph is going to have a negative slope working from left to right. So that would be that piece of the graph. All right. -2 to 2, we have no equal signs underneath these inequalities. So we're going to have open circles on this. And we have the constant 2. Now watch what happens here. At -2, the value is 2, and we would have an open circle here, but we already have a closed circle. So they're going to overlap each other. So we're just going to leave that. And we're going to do the constant 2 up to +2. +2 now has an open circle on its endpoint. All right, so that would be the second part of the rule. All right, third part of the rule, we would start at 2, x greater than or equal to 2. So we're starting at 2. We're going to plug in 2. And again, we would get 2. So we're going to overlap again that open circle with a closed circle. Now in this case here, the rest of the graph, 1/2 x plus 1, we have a slope of 1/2. So we have to go over 2 and up 1 to get our next point. And then our line would continue this way. So what do we have as our domain? Now, so when we write this in set notation, what we're going to say is we're going to use the squiggly brackets we're going to say x, and we're going to have a vertical line, and we're going to say um, x is greater than negative infinity and less than positive infinity. So we're going to use our inequality symbols for set notation here. All right, range. So our range, we can see that the lowest value on the graph would be +2, and then everything else is going to positive infinity. So we're going to use our squiggly brackets again. We're going to say y, vertical line, and we're going to say y is greater than or equal to +2, and squiggly bracket. All right, so I hope that this video was informative for you for piecewise functions, on how to evaluate and how to graph piecewise function. If you like this video, please like and subscribe. Thanks for watching.